All right, well, hi everyone. We're going to work with composition with inverse trig functions. We learned earlier in first semester that the inverse function of the function of x is x. The inverse function and function just cancel each other out. And the function of the inverse function is also, I didn't finish that thought, equal to x. This thought may not completely apply to arbitrary values of x and y. It doesn't always work with the trig as far as just simply putting that value there. We have to do a little bit sometimes. So, but for tangent, the tangent, when we take the tangent of the inverse tangent of negative 14, we will just get negative 14. And we can kind of check that. Tangent of inverse tangent of negative 14 is negative 14. So for tangent, that all goes. The domain of the inverse tangent is negative infinity to infinity. The range of tangent, the things we can put into the domain, but the range of tangents, the things we can get out, is negative infinity to infinity. So that checks out. Now the temptation here would be to put 7 pi over 4, inverse sine and sine canceling out. But if you'll recall that the range of inverse sine, what we can get out of here is negative pi over 2 to pi over 2. So I am going to look where 7 pi over 4 is, right here, and I'm going to make that fit in the range, the equivalent angle, so that it fits in the range is negative pi over 4, or coterminal angle, I should say. All right, cosine of arc cosine of 0.54 is 0.54. Okay, the cosine of an angle has to be between -1 and 1, and this is. Okay, now the sine of the inverse sine of pi. Okay, can we take the inverse sine of pi? And the answer is no, we can't. All right, if we take the inverse sine of something, the domain of inverse sine, it's got to be between -1 and 1. 3.14 is bigger than 1, so that's outside of that. So we're not going to get that answer. And in case you're curious, the sine of the inverse sine of pi, see if I can remember what pi is. There it is. Oops, I'm in something strange here. Is a domain error again. All right, so this is taken care of us here. Okay, if I'm going to take the inverse sine of something, that number has to be between -1 and 1 that I take the inverse sine of. All right, now evaluating compositions of trig functions that have different trig functions involved. I want to just give you a little strategy on that. And I think the easiest thing to do is just kind of to draw it out. So if I draw my y-axis and my x-axis, and we're talking arctangent, and the we're kind of looking at the angle here, where the arctan is -3/4. So I'm going to kind of draw a triangle here, my theta here. This is my right angle here. Okay, this is the angle I'm interested in. Its opposite is this right here, the 3. Its adjacent is this, the 4. And it looks like just by location, that our y-coordinate is the -1. And I think if you use to get this value here, the r value, -3 squared plus 4 squared equals r squared. And that's 9 and 16, which is 25. So r is 5 here. This is 5. So the cosine of this angle, okay, there is some angle that has this for its arctan. We wrote it right here. The cosine of that angle is the adjacent side, the 4, over the 5. Okay, let's look at this one. We're going to take the tangent of the inverse sine of 0.7. Okay, if we're taking the inverse sine of 0.7, I'm going to think of this as 7/10. Okay, so I have a positive value for the inverse sine of 0.7. And I'm going to be up here in this quadrant. So put my theta here. And the opposite side is 7. And this is 10. And this is the adjacent side. So I need to figure that out. And so a squared plus 7 squared is equal to 10 squared. So a squared plus 49 equals 100. A squared is 51. A would be, and it would be the positive, we're in the first quadrant here with our angle, is the square root of 51. So A is the square root of 51. The tangent of our angle here, we figured out this angle, is the opposite over the adjacent. So this is 7, the opposite side, over the square root of 51, and I'll rationalize the denominator. And I have 7 radical 51 over 51. Okay. Now, we'll get into, this is kind of not a calculus topic per se, but more of the abstract thinking that calculus would give us here. Okay, I'm going to just take this on. I'm going to do a part at a time. Let's let u equal the arctan of x. Okay, that implies from the inverse, if I were to take the tangent of u that would equal x. And that is equal to tangent of u equals x. That would equal the opposite side from x over the adjacent side from x. Tangent is opposite over adjacent. And if I make this x over 1, then I have this triangle. I'll just draw angle u right there. The opposite side is x. The adjacent side is 1. And I'm going to actually work on this hypotenuse here. X squared plus 1 squared is equal to r squared. So, and I only want the positive value for r, always just going for the positive. You know, we'd have plus or minus, but if I take the square root of both sides, the square root of x squared plus 1 would equal r. Now that is not equal to x plus 1. Please let that thought go away if that's what you're thinking. Okay, square root of x squared plus 1. Rewrite that. All right, now secant is the reciprocal of cosine. Now cosine is adjacent over hypotenuse. That means secant is hypotenuse over adjacent. So in our problem, the hypotenuse is the square root of x squared plus 1, and the adjacent side is 1. So that's just simply equal to the square root of x squared plus 1. Our final answer there. Okay. Now, we're going to do the same kind of thing here. Write an equivalent expression write an algebraic expression that is equivalent to the cotangent of the arcsine of 4x. Okay. So I'm going to kind of start the same way. I'm going to have a kind of a go-between variable here. Let u equal the arcsine of 4x. And I did ask this question. I have this idea that x has to be greater than or equal to 0 and less than 1/4. Maybe you can tell me why in class. So let u equal the arcsine of 4x. That means that the sine of u is equal to 4x, and that sine is opposite over hypotenuse. So I'll make that 4x over 1. So if I draw a u, I don't need to worry about drawing it in the standard position or anything, but if I draw that u here, the opposite side is 4x, the hypotenuse is 1, the adjacent, I'll just let that be a right now, a squared plus 4x squared is equal to 1 squared. So a squared plus 16x squared equals 1. And a squared would equal 1 minus 16x squared. And when I take the square root of a squared, I'm going to take the square root of 1 minus 16x squared. And I'm going to go with just the positive value. That won't simplify anymore. Okay, so x being positive or negative will take care of all of this then with that square and everything. So we're all good here. We are supposed to find, oh, let me look what we're looking for. So the cotangent of the arcsine of 4x, the cotangent of this angle is the one that has a sine of 4x, opposite over hypotenuse. What is its arcsine? I'm sorry, what is the cotangent of it? It would be the adjacent side over the opposite side. So I'll go with the square root of 1 minus 16x squared over 4x. All right, there we are.